All right, let's see where we are. So first thing to go over when you're talking about programming languages, that is just a common thing to know when you're going into, I don't know, coding or programming, is that there's different data types you're going to be working with. So the first one that I'll talk about real quick is strings. Strings are essentially just a combination of characters. They can be letters, numbers, or symbols. And so like, for example, here, so we're creating a string variable. So this where it says string is that's just a name of a variable that we're setting. And then you can see this is the actual input that is the string. So you see we have spaces in there, we have letters in there, we have numbers in there. And if we run this, oops, let me take out type. So you see we created the variable, and then now we're printing out what type of variable it is. So when we run it, I'm up the bottom right. Where? Yeah.
Yeah, no. Yeah.
There's, oh, okay. There we go. So, oh, okay. This is interesting because we have other stuff going on here. Just pay attention to this first line. There's other stuff running, but essentially what we're just looking at right here is this first line. So it's just saying that this is a type of string variable. Okay, so then the second type of variable or second type of data that we're going to be talking about is numbers. There's a couple different types of numbers, which is weird, but it can essentially be an integer, meaning that it doesn't have decimals, or it can be a float data type. So that means that it does have decimals. So like right here, if we're setting this variable number 1, that's just the name of the variable. And then the actual input is 123. So notice there's no decimals. So when we run this and get the type, you can see I have like so much other stuff. Hold on, sorry. You guys know why it's like, oh, nope. Okay, we have a lot of stuff printing real quick. So let me just do this. I'm just gonna do all of it. Sorry, one sec. Is it Control / Okay, there we go. Okay. Let's try that again. Oh, we have to print that out. I'm sorry. It's taking a minute. Okay. So let's try that again. We're going to run that chunk of code real quick. And now we see that our type of that is integer. So it's not a float because it doesn't have any decimals. Okay, and then down here, if we're creating another variable that does have decimals, so like now we have a new variable called number_2, and we're assigning it 123.4. So this is going to be a float since it has decimals. So let's print out the type here. And we can see this one is a float data type. The next data type is Boolean or bool. Essentially, this is just a data type that takes values true or false, 0 or 1. And these are going to come, I guess, back into play later on when we talk about conditionals. But for right now, I'll just kind of show you a little example of what they are. So say we're just setting a variable named happy to true. If we run that, then we can see, run that. So when I'm doing print here, it's just a function that's getting the result to actually display. So now we can see the class or the data type is bool or Boolean. I'll skip that one because it's exactly the same, but essentially I could set it to false also. And then the type would still be bool, it's just true or false. So if we want to look at variable creation, which we've already kind of been doing, you can see every time I've been looking at a different data type, we've been setting a variable or initializing a variable is kind of what it's called. We're doing that with the equal sign. So what's weird is that you would expect that the equal sign is equals, right? But it really doesn't mean that. It's simply used to assign the variable to the variable name that we're setting it as. And then keep in mind that the variable names that you're using, they can't have spaces in them. So common ways to name variables include using underscores or kind of using like this little uppercase in the middle to kind of separate the words in there. So say like right here, this would be an example of creating a variable, which we are saying variable name, right here is the name of it. And then you're assigning this value. So this is a string and the actual value is variable value in this case. We don't really need to run that, but if we were to run that, it would set that variable name to that value. Actually, we could do that and then we'll print it. Now you can see if we print that out, it's going to give us the value of that variable name. Okay, and then so keep in mind that since we have so many different data types, there's something called casting. So it's essentially converting a variable from one data type to another. This typically comes into play when you have a number that is essentially in the data type of a string. So like right here, we could create a variable called casting example and set it equal to 123.5. But in this case, it's a string, right? It's in quotes. So this number is currently a string, and we can show you by printing it. You can see here, even though that's a number or what we know as a number, it's still a string variable type. So we can reassign this variable to a different variable type, or sorry, data type, by kind of using these functions that are in Python or in whatever language you're using. And this whole process is called casting. So for example, we're going to create a float variable since it has a decimal, and we're gonna just keep it the same name, but we're gonna reassign the data type as float. So use the float function, and then we'll reprint that data type after we create it. Okay, so now after we use that float function, now we can see that the type is printed out down here as a float. So that's probably the most common example of when you would use that potentially. So like we wrote down here, the integer function, the string function, and the float function are useful ones that are built into Python for casting. The functions in other languages to do the same type of thing vary, but the idea is essentially the same. So you'll just have to figure out whichever functions in the specific language you're using are. So also, I want to just quickly go over some operations. Most languages have built-in numeric operators available for users, including like addition, subtraction, all that good stuff. So real quick, addition is just the plus sign. It's pretty self-explanatory. So say we have number 1 and number 2 variables assigned to 2 and 7. we can just do, we assign those variables and then use that plus sign to add them together. We get the result of 9 equals 7. So cool. Subtraction, same thing. Say we have the same two numbers. So this is essentially doing 7 minus 2 here. Okay, yeah, so 7 minus 2, 5, cool, self-explanatory again. Division is just this slash sign. I'm not even going to run this because it's exactly the same as the other two. Floor division is the same thing, but it's 2 of the slash marks. So floor division essentially divides, but then just drops off any decimal that there is. So say we do, let's do 7 divided by 2 here. We all know that's 3.5, right? But if we run that, it just gives us 3 because it's dropping off that 0.5. What the floor division is, all these kind of work in every language. Multiplication is this little star sign, the asterisk. I'm not going to run it because once again, it works the exact same. Exponentiation, exactly the same, so I won't run it, but it's those 2 of the little asterisks is exponentiation. So if we were to do, if we were to do the variable num2 and then 2 asterisks and the variable num1, we'd be doing 7 to the power of 2, essentially. Modulus is the little percentage sign. It essentially is just returning the remainder of the division. So this is a good way to find out if a number is even or odd. So if you're dividing by 2 and you get remainder 1, that shows that your number is odd, obviously. So once again, I won't run it, but you're really only going to get the remainder of the division. It seems like you might not use it, but oftentimes it's used to figure out if a number is even or odd. And then these operations weirdly can also be used on strings. So say we want to combine these 2 variables, A and B. So we want to combine hello and world and have them put together into this one variable C. So we can actually add this string variable A, which is hello, plus a space, plus the string variable B, which is world. And if we print that out, you'll see that it just prints the first string plus the space plus the second string. So it's kind of interesting. You can actually use some of those on strings as well as numbers. And then you can also index elements of strings. I know we talked about strings earlier, but we're going back to them a little bit. So so if we want to pull out, like say, the second letter of this whole string, we can index it out. So C is our variable name, right? And we're using these square brackets to index out the, I guess, what's in the first position. Note that with Python, indexing starts at 0. So when we're using a 1, we're actually pulling out the second letter in it. So like when we run this, we should be getting an E because H would be the 0 index and E is going to be the 1 index. This is something you kind of got to keep track of. For Python, it starts at 0. For R, it starts at 1. It varies between languages, so just make sure you're sure of that when you're running anything. And then there's some comparison operators I'll go over really quick. We talked about how 1 equals sign doesn't actually mean equals. It means assigning a variable, basically. If you do 2 equals, that's what truly means equals. So if we were to run like 7, if we were to run 7 equals 7, we know that that's true, right? So run that, and we see it's true. If we were to run 7 equals 8, we would get false. So basically, that's just a comparison operator for what actually means equals. Not equals is the same exact thing. However, it's an exclamation point and an equal sign. I won't run these. It runs the exact same way, but essentially if it's not equals and that statement is true, it'll report true. If not, it'll report false. There's similar ones, less than, greater than, less than or equal to, greater than or equal to. They work exactly like you learned them in elementary school. And they work the same way as the other two. They'll return true if it's true and false if it's false. And then we have a couple logical operators. So this kind of has to do with the Boolean stuff I mentioned earlier, but essentially we have and returns true if both statements are true. If even one of them is false, it will return false. So say we have this as our, I guess, statement. So we're trying to figure out if 7 equals 7 and 6 is less than 8. We know that both of those statements are true. So this should return. Sure. Perfect. And then so like for the second one, for example, one of them is false. So we know that 7 does not equal 4, right? So this, since even one of them is false and it's an and operator, this whole thing is going to return false. Okay, or it works the same way, but it will return true if one of the statements is true, or if, I guess both of them are true. So like if we have 7 equals 7 or 6 is less than 8, even though both of them are true. The or is just looking to see if one of them is true. Yeah. Wait, repeat your question. I'm sorry. Oh, you're trying to say like, will it tell you which piece of it? No, I'm sure you could write code that would give you that information, but like just running this simple thing, it's not going to tell you which piece is false, I guess. I'm sure you could just write something that would give you that information. Does it? It's an error.
You what line is there is on, and over here it tells you specifically what is wrong about that line. And sometimes if there's like invalid syntax or something like that, it'll put a little caret under where it thinks it is. So I know other programming languages like do that for sure. I'm not too sure right now if Python does that, but yeah. And also in other programming languages like each line has a number and each character on the line has a number. So it'll tell you where the error is like character-wise. So I can see that. So yeah.
Yeah, errors kind of show you where it is. Okay. So essentially we have and, we have or, and then we have not. This not essentially just takes whatever the thing inside the parentheses would return and then returns the opposite. So like if we run not 6 is less than 8, we know 6 is less than 8 is true, right? So that not is going to make it return false, essentially. Same thing down here, but it would be opposite, right? 6 is greater than 8 is false, and not would make it return true. Real quick, I'm going to go over lists. They're basically just used to store multiple items within a single variable. These are used in like every language. You create a list by assigning it to a variable name, and you use these brackets essentially to put in the values. So right here, we'll create a variable named fruit that contains the list of these 3, I guess, fruit names, right? So we have 3 different items in our list. And then if we assign it to this variable name and print it, we'll get the results of that. So you can see it prints out the 3 items that we have on our list. Same thing down here. This is just showing that essentially you can have different data types within a list. So like here we have an integer, then we have a string, then we have a Boolean, then we have a float, right? So we can do all of that within one list and it won't give us an error. That's fine. And then we can index a list. So this is essentially how we access different pieces of a list. So I mentioned this earlier, but in Python, indexing starts at 0, in R it starts at 1. Just make sure you're careful about that. So for example, if we want to pull out the first item of the fruits list, we can print out fruits and then do those square brackets and a 0 because 0 is the first index. And it will print out cherry, which was the first item in our list. And then we can also slice a list. So say we want to pull out a couple different items, not just one. Then we can just do like those square brackets again, but say we want to pull out items 0 through 2. Notice that the last number here, this 2 is not inclusive. So when we run this, we're going to get cherry and apple. We're going to get index 0 and index 1. We don't actually get index 2. That's just kind of something you have to know and work with. If we wanted to get that last element, that second index, then we would have to increase that up to 3. We run that. See, now we get them all. Yeah. Yeah. Like that, you mean? Like index from 1 to 3. You can. I cannot say I remember exactly how to do that off the top of my head currently. Connor, do you know how to do that?
Yeah, so you can't do it. Slicing gets everything in a list. So if you would want to have a list of like just cherry and banana, you would have to do is like lists have operators. So remember how like with the string you can just do plus and it adds the 2 strings together? You can actually do the same thing with lists. So if you did like fruits 0, which is cherry, plus fruits 3, you could get a little like a list of you can step, and in this case, stepping would work, but then it would. I'm sorry, yeah, are you asking, do you want to list with every other item or just sharing the every other one?
Oh, I did not. Okay, yeah. There we go. You could add a space in there too. Okay, adding to a list, if you want to add something to the end, you can use the append function. So essentially, say we want to add mango to our list. We can do fruits, so the name of our list, dot append. This is our function name. And then in parentheses, we're going to put in the value that we want appended to the end of our list. And then we'll reprint it after. So now we can see we have the original 3, and then we added mango to the end. And then you can add also more than one item to the list, but you have to use a different function. So say we wanted to, I guess, extend the list to include strawberries, pineapple, and watermelon. So put those in a list on their own called more fruits. And then we can extend our original fruits list by putting in all of those at the same time. So just throw that variable name of more fruits into this extend function. And then we can print out our results. And you can see now we have our original 3 plus our new 3. And then you can also insert stuff at a specific point. Use the insert function. You put the index where you want it to go and then the name of what you want to put in. Run that real quick. So see, we have now, so I didn't reassign this to a new variable name, so that's why it's not keeping those last three in there. But essentially with this one, we're putting the orange in the 0 index position. So it's going to be our first one. And then replacing values, same thing. You have to index out the position you want to put it in or replace. And then put your value you want to replace in the equals. So we're creating basically the fruits index 0 to be grapefruit. Now we have grapefruit, apple, banana. Cool. You can remove an item with the remove function. That's pretty self-explanatory. I will run it for you so you can see how it works. The reason it's not in there is because I'm not actually reassigning this to the list name, so it's not permanently changing it. But apple was already in there, so that. Now we took out apple, and now cherry and banana are what's left. And then you can also use the pop function to remove something by its index position. So, for example, here, if we want to take out what's at index 0, we do fruits.pop and then 0 within that and reprint it. And now we took out the first index, which was, I think, orange. All right, cool. That's all I got for you.
I'm just going to talk about functions. So before I start, any questions on what Michaela covered? No? Okay. All right, so I'll start talking about functions. So what is a function? Function is kind of just like a chunk of code that like does something. So like if you guys are familiar with Excel, like Excel function, kind of similar here. So you can make your own functions, and Python already provides you some like built-in functions. So I'm just going to go over some of the built-in functions. So before I actually talk about functions, they take in an input and they give an output. So not all the time they'll take an input and give an output, but most of the times you have to give them an input and they'll give you back. So here's some functions that you can run on a list, assuming that that list is a list of integers or floats. So the first function I'm going to talk about is sum. And the way you call it is you just type in sum, and then you want to put these parentheses to indicate that what you're doing is calling a function. And then inside that function, you want to pass in the value that you want the function to be, or the data that you want the function to be applied to. So we call this right here, like the thing that you pass in, the parameter. So the sum function will literally just take the sum of this list. The max function will find the max of the list and return it to you. The min function will find the minimum of the list and return it to you. And the length function will return the length of the list. And this is another function that's called the range function. This doesn't really work on lists, but this returns something that's called an iterable. And it's not a list, but it's kind of like one a little bit. Basically, if I do like range 5, will be returned to me is something that contains 0, 1, 2, 3, and 4. So it's not inclusive of the 5. And I'll talk about why you'd want to use range a little later when I talk about list. So let's just run this and see what its output is. All right. So the sum function outputs 15, which is the total, and then max is 5, min is 1, and the length is 5. All right. So like I mentioned earlier, you can create your own functions. So I'm going to talk about how to do that. So first thing you want to do when you want to create a function is type in this def keyword. And the def keyword indicates that you're going to create a function. Then after that, give the function a name. So let's create a function that just adds two values together. So we'll call our function add. And then what you want to do is put parentheses. And then inside these parentheses, you want to define the parameters. So like up here, how list was a parameter, I want to define what I want these parameters to be. So you just give them like a random name. So I'm going to call mine A and B. It doesn't really matter what you name them. And then after that, you want to put a colon. And then if you press enter, you'll notice that all the lines after that are indented. So what that colon and the indent means is that all the code after this like colon that's indented is part of that function. So let's define a variable called result, and we want it to be equal to a plus b. All right. Now let's call our function. So the way you call your function is you type in the name, you put the parentheses to indicate that you're calling a function. Then within the parentheses, you type out the parameters that you want. So 1 and 2. So let's print this and see what happens. So as you see, it printed out none. And the reason why it's printing out none is because the function doesn't know what to give back to. So we define the parameters a and b, which indicates what the function wants as input, but we never specified what is the output. So the way that we can define output by using another keyword called return. So if I do return and then result, now whatever value is stored at result will be returned from this function. So it'll be given to me as output. So let's run this one more time. As you can see, it returns 3. So one interesting thing about return is that all code after return in the function will never be run. So if I print out something like hi, right, which after it's returned, and I run this code again, that print statement doesn't get run because the function stopped running the code after the return. So now I'm going to be talking about scope, and this is pretty important for understanding like functions. So this is another function called add2, and it's pretty much the same thing as the function we wrote above. So as you can see in this function, I define this variable called the sum. So now I'm going to try to print out the sum which I defined inside this function. So let's see what happens when I try to do that. And it gives me an error and says the sum is not defined. You might be kind of confused because sum is defined right here, but we're unable to print it out here. And that's because of scope. So like I said earlier, if you want to give something to a function, like data to a function, you have to pass in data through the parameters. And if you want to get things out of a function, you need to use this return keyword. The function doesn't know about anything, any code outside the function, and the code outside the function doesn't know about anything inside the function. So the parameters and the return are the only way to transfer data between those two. So that's why that error out. Okay. Next, I'm going to be talking about conditionals, and these are just kind of like if statements. So if you are familiar with Excel if statements, kind of similar. So the format of them is you type in the keyword if, then you put a boolean, and you have your code under. And if you notice, the colon is there after, and the code is indented, and that's to signify that the code that's indented under that if statement only gets run if that boolean value is true. So let's look at an example right here. So I have if true, print always enters this if statement, and if false, won't enter this statement. And as you can see, let me get rid of this. As you can see, the second thing didn't run because that boolean was false. So it's kind of useless to say if true or if false because that always gets run or always won't run. So you wanna check like a boolean and check if something in your code. You can use those like conditional operators that Kayla talked about earlier. So if you guys remember, this conditional operator returns a boolean value. So if x is equal to 5, it will return true. And if x is not equal to 5, it will return false. So since x is equal to 5, it returns true. And what we can do is we can use that in our if statement to check we can use that in our if statement to check whether x is 5. So if x is 5, we want to print out this string x is equal to 5. So let's run that. And since x was equal to 5, it prints out. So you can have multiple if statements in a row and they'll run consecutively. So like x is equal to 5. So since x is greater than 3, it'll print out x is greater than 3. Since x is greater than 4, it'll also print out x is greater than 4. And I want to bring I mentioned that because I want to talk about elif. So in Python, this is called elif, but in other languages, it's usually called else if. And the reason this differs from this statement, this code up here, is that if the first if statement, the condition is satisfied, it won't run that second if statement. So for this one, it printed out both these sentences, right? But if I run this one right here, it'll only print out x is greater than 3, even though x is actually greater than 5, because we use this elif, it won't even bother checking this condition, since this condition is satisfied. So let's say you want something like an elif, but it's kind of like a catch-all. So if none of your conditions are met, just do this instead. That's where the else keyword comes into play. So if your condition isn't satisfied, then it would just go to the else and do whatever code is defined in the else. So I said if x is greater than 10, print x is greater than 10. Else, print x is not greater than 10. And it's going to print x is not greater than 10. Okay. Yeah, I was going to talk about loops, but I think we're out of time. So is there any questions about functions and conditionals? Oh, I use control / I probably should have clarified that earlier too. The code with the here the hashtag before it is commented out. So that just means everything that's commented out won't be run. So if I type in something like else right here, right? I try to run that. It'll think else is like a variable. So I have to comment it out, and that's how you can like write on your codes and like talk about things that are going on your code. So yeah, you can either just like literally just like if you have something written out, you can go before it and then just press like the pound key. It'll comment it out just like that. Or if you want to comment out like multiple lines, what you can do is like the single quote. If you press it 3 times, you put the things you want to comment out in those two. It'll comment out those. They kind of look like strings, but they're commented out. So yeah. Do you have any other questions?